All right, let's get straight to it. The modern battlefield is being fundamentally reshaped. And no, it's not by massive tank columns or fleets of stealth fighters. Today, one of the most significant threats can come from a swarm. In this briefing, we're going to dig into one of the most pervasive aerial weapons out there right now, and more importantly, break down the complex strategies being built to stop it.
And this really gets to the core of the problem. We're talking about systems like the Iranian-designed Shahed drone. I mean, for a tiny fraction of what a traditional missile costs, these things are causing an insane amount of damage. It's a textbook case of asymmetry warfare, and honestly, their whole design philosophy is what makes them so incredibly difficult to counter.
So, to figure out how to defend against something, you first have to dissect the offense. We need to get inside the design of this weapon. You know, what makes it tick? What makes it so darn effective? Let's start the threat assessment.
This right here is the million-dollar question, or, maybe given the drone's price tag, it's more like the $20,000 question. How in the world are these relatively simple drones getting past some of the most sophisticated air defense networks ever built? Well, the answer is this potent mix of low-tech physics and some very clever high-tech strategy.
What's so interesting here is how it uses pretty basic principles to fool very advanced defenses. First off, it's small and it flies low, which makes it incredibly hard for radar to pick it out from all the background clutter on the ground. It's like trying to spot one specific bird flying just above the waves. On top of that, it's built mostly out of plastic and fiberglass, which barely show up on radar systems that are calibrated to find big metal fighter jets.
Now, as effective as those physical tricks are, that's not the main story. The real secret sauce for the Shahed, the thing that truly makes it a 21st century weapon, is how it finds its way to the target while actively dodging electronic attacks.
And this is the key, the Inertial Navigation System, or INS. It sounds super technical, but it's actually an old-school concept just supercharged for today. Think of it like this. You're in a pitch-black room, but it's a room you know well. You can't see a thing, but you know where the door is. By remembering where you started and just carefully counting your steps and your turns, you can get to that door. That's INS. It doesn't need any signals from the outside world. It just needs to know where it started and where it's supposed to end up.
And this just lays out the tactic perfectly. So the drone gets its GPS coordinates right at launch, and then it immediately goes dark. It literally turns its GPS receiver off. Now, why would it do that? Well, because the #1 electronic defense is GPS jamming. But you can't jam a signal that the receiver isn't even listening for. So the drone flies almost the entire way blind, using that internal INS, which makes it totally immune to jamming. Then, maybe, just for the last few seconds, it might flick its GPS back on for one final tiny course correction. It's a simple idea, but it's devastatingly effective.
Now, this is a really crucial point. You might be thinking, well, an INS can't be as precise as a live GPS signal, and you'd be right, it's not. But as analyst Thomas Withington points out, it doesn't need to be. When your target is a massive power plant or a big military staging area, being off by a few meters just doesn't matter. It is absolutely accurate enough to get the job done.
Okay, so we've laid out the threat profile. It's stealthy, it's electronically tough, and it's cheap to build. So now, let's flip the coin and look at the counteroffensive. How do you actually fight back? Broadly speaking, the defensive strategies fall into two main camps.
On one side, you have kinetic intercept. You can think of this as the hard kill approach. It's direct, it's physical, it's pretty easy to understand. You shoot the drone down. On the other side, you've got electronic warfare, or EW. This is the soft kill. Instead of a big explosion, you're fighting a battle on the electromagnetic spectrum. You're trying to jam its signals, or maybe even spoof its navigation to trick it into flying off course into nowhere. But here's the thing. On a real battlefield, you don't really have the luxury of picking just one. The choice isn't kinetic or electronic. The reality on the ground is way more integrated, like a complex dance between shooting things down and frying their circuits. And we've got the data to prove it. Just look at this analysis from the conflict in Ukraine over a 2-month period. It's pretty telling. You see, over 6,000 drones were taken out kinetically, shot right out of the sky. But then look at that second bar. More than 4,600 were neutralized electronically. I mean, those numbers are incredibly close, which proves that both of these methods are being used together at a massive scale. So the takeaway here is crystal clear. The only strategy that really works is a layered defense. You can't just rely on one thing. You use electronic warfare as your first line to disrupt and confuse the swarm, and then you bring in your kinetic interceptors, your cannons, your missiles, to take out whatever manages to get through. It's all one big integrated system. But of course, the story doesn't end there. It never does.
This is a dynamic, constantly shifting tech arms race. For every single new defense that gets rolled out, you can bet there's a new offensive countermeasure already on the drawing board. The battlefield is always evolving.
And we're already seeing what's next. We're seeing drones with way more sophisticated anti-jamming antennas. They're being built to use multiple satellite systems, not just GPS, but also China's Baidu and Russia's GLONASS, which makes them much harder to block. There's even talk of bringing back older radio navigation tech like LORAN, which is totally immune to satellite jamming. The offense never stops adapting.
Which, of course, leaves us with the ultimate question. In this relentless back and forth, this constant race between the cheap, adaptable drone and the complex, expensive defense system, who really has the long-term advantage? The answer to that question is probably going to define conflict for decades to come.